Hi, my name is Aaron Ho, and in this video, I'm going to be going over the SA node action potential, the conduction system of the heart, and the electrocardiogram wave, and how it relates to the conduction system of the heart. Starting off, we're going to be talking about the SA node action potential. So in this graph over here, this is showing the action potential of an SA node firing off. So as we see here, the start of the graph, this is the resting membrane potential of the SA node, and it starts off at -60. As you see, there is a slow increase in the membrane potential, as we see here. And this line is the threshold. So this slow increase is due to the slow influx of sodium ions. Since sodium ions are positively charged, so will the membrane potential. It will be increasing positively. So as you see over here, there is a rapid increase in the membrane potential of the graph. This is due to the fast influx of calcium and sodium ions, which will cause it to shoot up so rapidly. In this graph, the membrane potential will reach a peak at the top, and then there will be a rapid decline. And this rapid decline is contributed to the opening of potassium ion gates, which will allow the potassium ions to flow out of the cell. And potassium ions are usually positively charged. So if the positively charged ions are flowing out of the cell, the membrane potential will decrease in value. And as you see here, after the SA node fires once, it will go below the threshold for the membrane potential. The membrane potential will go below the threshold and reach a membrane resting potential of -60 again. And as it makes its way up to the threshold, with the influx of sodium ions, this will be called the pacemaker potential, as it will be making its way toward the threshold to do another action potential and fire again. As you can see here, this graph shows the SA node firing twice. Moving on, we're going to be talking about the conduction system of the heart. So we have 4 different parts that contribute to the conduction system of the heart. We have the sinoatrial node, or the SA node. We have the atrioventricular node, or the AV node. We have the atrioventricular bundle, and we have the Purkinje fibers. So starting off in the first step of the conduction system, the sinoatrial node, which is the pacemaker of the heart, this will control the heartbeat and the amounts of beats per minute we have. The job of the SA node is the most important, as it will keep the heartbeat consistent and steady of about 70 beats per minute in each human being. So once the SA node fires, this will excite the myocardium in the atria. And then this will excite the AV node and cause it to fire off. When the AV node fires off, it will excite the atrioventricular bundles, which will bring the electrical signal down into the ventricles, which will excite the Purkinje fibers. This will allow the Purkinje fibers to become activated and allow for the ventricles to contract and complete one cycle of a heartbeat. And after each heartbeat, the cycle repeats again. And this correlates to the electrocardiogram wave, as we see over here. And the electrocardiogram wave, we have the P wave, QRS, and the T wave. So starting in the P wave signifies the firing of the SA node. And once the SA node fires, the atria will depolarize and contract. So over here, this correlates to the SA node as it fires off, and then the AV node will also fire off, which will allow the atria to contract. And this also relates to the atrioventricular bundles as well, as this leads up to the contraction in QRS of the ventricles. In QRS, the ventricles will contract, and this is mainly due to the Purkinje fibers being excited and allowing for the contraction of the ventricles, which is indicated in the QRS wave. Leading up to the T wave, this is the ventricular repolarization and relaxation. And this is after the atria and the ventricles have contracted. The ventricles will eventually relax and be ready to repeat the cycle again.